why fractions are hard. And I reckon that fractions are really one of the most difficult concepts in mathematics. There's a surprising number of intelligent adults holding down big jobs who really never got fractions and nothing else made sense after them. And I think once you do get fractions, you'll find there really isn't much that's harder than it in mathematics. There's a lot to it.
Because I must say, I did get fractions, which was really odd for someone who's not necessarily a mathematical genius, but so I'm feeling pretty good about that.
Well, you should, because there's probably concepts that are as hard. I can't think of anything that's actually harder than this. We just tend to do it very early in school.
Yeah.
So the background, imagine you're living in the ancient world and you were going, well, let's exchange, we'll have an exchange rate of 1 basket of wheat for 2 fish. And then you go, but I don't have a whole basket of wheat. I've already spent it buying half a pyramid or whatever I've done. How many fish do I get for that? And so you need a way to talk about that. It's really moving from the relatively easy concept of how many of something there is through to a more difficult concept of how much. So we want that
how
wall
many to how much.
How much to be, so we want that. We want the wall to be, planning the wall to be 8 cubits or whatever the measure was. Should we move it to 9 cubits? Well, no, because that blocks the light. I just wanted something more. Well, how much less than do you want? So when you need to break things down, and when you think about it, this is a really, if you didn't know fractions, this is a really hard thing to do. How can we take something that's not whole numbers, and it could be any size at all, any part of a whole number at all, and we need a way of describing that bit that could be anything.
Yeah, okay.
And it was the Egyptians who first cracked it, or at least who first started doing it, writing it pretty much the way we write it, the idea.
Clever bunch, the Egyptians.
They really were. So you start with a whole of anything, and you can divide it into as many parts as you like. And in this case, we'll divide it into 6 parts. We then draw a line over that. The Egyptians didn't, but that's about the only way we've changed what we do from what they do. We call that the denominator. In other words, we name the number of parts we're dividing it into. So denominate, and then we pick a given number of those parts, which, because it's the number of parts, we call it the numerator. So in this case, we've got one.
That's what numerator is. Just means number of.
Number of whatever we've named.
Okay.
So that's 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6, which is a fairly clever idea. So what makes that hard? Well, one of the things is that if we look at 2/6, you can see that's exactly the same thing as 1/3. 3/6 is the same thing as 1/2.
Okay. So this is where it gets messy for people, is it?
It's one of the places, because what it actually means is that if you multiply or divide the numerator by the same amount, the numerator and the denominator, by the same amount, the fraction stays the same, which is kind of like, well, how do you do the top and the bottom but it does. So in this case, if you multiply the 1 by 3 and the 2 by 3, you've still got exactly the same fraction. It hasn't changed. If you divide the 3 by the top, the numerator there, by 3, it hasn't changed, provided you divide the 6 by 3 as well.
Right, okay, so that keeps it consistent.
Keeps it consistent.
That's
if you
word,
multiply that 1 over 2 by 50, so you've got 50 over 100, which means that's just saying 50%. It's just a shorthand way of saying over 100. So 50 over 100. What that means in turn, if we call that 50 over 100, if we call it 1 by 50 times 2 by 50, we can do what we call cancelling out, which is really saying divide the top and the bottom by 50. It gets us back to a half, but it's all the same fraction.
Ooh, I've just got a bit of kind of excited about that. I knew there were different fractions, but I hadn't quite seen the relationship between them. You're getting at here, how they're expressing the same thing in different ways.
Expressing the same thing in different ways. Exactly right. All the same thing. The second thing about it is that makes it kind of hard is when the denominator gets bigger, the fraction gets smaller. That's kind of counterintuitive.
Right. Okay.
So 1/3 is smaller than 1/2, which is, and 1/6 is smaller still. when the numerator gets bigger, the fraction gets bigger. When the denominator gets bigger, the fraction gets smaller, which is fine when you got your head into it because it's more bits you're breaking it into. So each bit has to be smaller. But if you're not familiar with it, it takes a bit to get your head around.
It's where, again, the diagrams we've got here are really helpful because you can visually see the chunks, the size of the chunks, which is, I find, really helpful as well.
Good. Now, the third thing is if you add two fractions, you've got to add the numerators but not the denominators, which makes sense when you see it like this. You add 1/6 plus 2/6, then you're going to get 3/6, which is the same as a half. But sometimes you think, should we be adding the denominators? No, not when you see it like this. Now, when we have two different denominators, we need to make them the same thing. It's like, otherwise we're trying to add two different things together. It's like trying to add 2 plums to 3 oranges and say, how many bananas do we have? Whereas if we go
that just messed with my head, John.
But if we go 2 pieces of fruit plus 3 pieces of fruit, that's easy. That would be 8 pieces. No, just joking. That would be 5 pieces of fruit.
Yeah.
So what we need to do is find a common denominator, and we can do that. We've divided our block into 6, but we can, as well as dividing into 6, we can go horizontally and divide that into 7, and that means we've now got 42 blocks there.
Ooh, can you just do that again?
Yeah. So we've got 6 horizontal columns.
Yep.
Now, if we make that into 7 vertical rows,
yes. Okay.
then all together we have 42 blocks, and we have that. If you multiply the 6 along the top by the 7 down the side, that gives us 42. So essentially what we've done is multiplied our 2 denominators together, 6 by 7, and because whatever we do to the bottom of a fraction we need to do to the top, we multiplied 6 by 7 to get 42, therefore we need to multiply the one on top by 7, so that'll give us 7 on 42. We multiplied the 7 by 6 to get to 42, so we need to multiply the 2 by 6. Altogether, that gives us 7 on 42 plus 12 on 42, and that's then easy to add up, so it's 19 on 42. So, pardon me, so 7 of the 42 plus 12 of the 42 makes 19 of the 42.
Yeah, okay.
Find a common denominator.
Oh, this is exciting. I just had a glimpse emerging from my primary school years. About finding the common denominator.
Finding the common denominator. That's now. That's what they meant by denominator. Yeah, okay. Now, when we come to multiply it though, what really messes us around is we just think, well, multiplying should surely be more difficult than adding, but multiplying becomes easier.
Right.
So we still start with a common denominator. So we want 1/6 times 2/7. It's still going to be something on 42. So we've still got our 6 by 7 block there. But to find out what's on top, if you think about what we're doing, we take 2 of those 7 rows, so that's 2/7, and we want to find 1/6 of that. It's neatly divided into 6, so if we find 1/6 of that, that is altogether 2 or 1 by 2. So we've kind of multiplied the bottom to get the whole lot that we've created, and then multiplied the numerators to get the bit that we're taking from that. If we were to change that around and say, okay, we'll pull it 2/7 by 1/6, we'll go, okay, well there's 1/6, one of the columns, and neatly divided into 7ths. So should we then go, we want 2 of those 7ths. Again, we've got 1 by 2, same things.
Oh, yeah, okay.
So to multiply 2 fractions, multiply their numerators and their denominators, but what often happens is people come back to fractions later in life and go, well, hang on, how did that work and so on? It seems strange that it's easy.
It's so easy to do it is.
With multiplication. It kind of throws people out. And just on that, just side of that, there's a thing called a reciprocal. So a reciprocal means you swap over the numerator and denominator.
Okay.
Got 1/3 there. 3 on 1 is the same as writing 3. So it's just 3 broken into 1 bit, so 3 bits. And so 3 on 1 is the reciprocal of 1 on 3, and that always adds up to 1. Oh, sorry. jumped ahead. Always as it to ones, because we're going to have 3 on the top, 3 on the bottom. We can divide top and bottom by 3.
And why would you do that?
Why would you multiply something by its reciprocal?
Yeah.
Oh, we'll get to see that in a later video. Just an example of why
that's for a flag.
Okay. Yeah. When we come to look at
so at the moment,
powers is one of the things.
That's about all right. Okay.
We'll use it for all sorts of things, but it's just useful to know now that when you multiply something by its reciprocal,
it's reciprocal. You get 1.
Got it. Good question. Stay with that.
That's another little emergence from the fog of primary school, so I'm excited about that as well.
Oh, good. Good to be emerging things from your fog. The third thing is that comes out of that, when you multiply 2 fractions that are between 0 and 1, the result's smaller than either. So,
run that again, John.
Yeah. If you multiply 2 fractions that are between 0 and 1, the result is going to be smaller than either. And automatically we tend to think, you multiply 2 things, they should get bigger. But if you say a half times a quarter, well, that's going to be a quarter of a half, which is an eighth, and this becomes really important in probability. We're jumping ahead of ourselves, but we describe probabilities as fractions. You might say there's a 60% chance of rain or 3/5 chance of rain. That's how probabilities are spoken about. And there's a thing called the multiplication rule. Don't need to worry about it now, but what it says is if we want to know whether both things will happen, we multiply the probabilities, but that actually means there's a smaller chance of 2 things having to happen than 1. Yeah, because once you multiply 2 fractions, they get smaller. But it throws a lot of people out when they first come to the multiplication rule. And how does that work? It's because they get smaller.
This is what I'm getting as we're working together on this, is that all these pieces build to something. And I think when we were chatting off air, it was about, for me, it was always just little individual pieces that didn't connect. But what I'm finding helpful about this is that we're taking all these bits that are building a whole picture. So
that's exactly right. It's a bit like a jigsaw, and if you don't know where it's going, it becomes less frustrating the further you get, the more you can go, actually there's a beautiful picture there.
Well, I just had that happen then when you were talking about probability. So
right.
Going, oh, okay, that makes sense. The probability of 2 things happening, but we're jumping ahead.
This is heading somewhere, but when you do it just a bit 1 year in school, fractions
unrelated.
No idea how that relates to anything.
Sure.
Yeah, no, that's
cool.
That's right. So it's challenging to learn this stuff in school. In some ways, it's easier to come to it later. The final thing, so that's the 7 things that make fractions challenging. The final thing is that fractions have nuances. Mathematics is like any other language, and it's all got nuances, but fractions have a lot more nuances than most things.
Okay.
So if we were thinking about 3/4, we could say, okay, well that says 3/4 is part of a single number. Is one way to think about it. So it's less than 1. It's 3/4 of 1. It's also part of anything else. It can be part of an orange or part of the national debt, or it can be part of anything you like, not necessarily part of a single number. It can also mean division. So 3/4 is 3 divided by 4. How many times will 4 go into 3? Well, it will go 3/4 of 1 time.
Yeah. Right.
And it's also a proportion. 3/4 of the crowd were supporting the home team, so they wore red. So that's the proportion term. It's also a ratio sometimes. It's sometimes a ratio of 3 to 4 and sometimes not, which can itself be a whole confusing thing about it. It can actually, when we come to look at the slope of a line, it can describe the slope of a line, and we just mentioned it can refer to probability. It can probably refer to more things than that. And the good thing about it is you don't have to say to yourself, now we're talking about a ratio here, or we're talking about it doesn't matter. The rules all work the same way.
Okay.
But one of the reasons it can be confusing is it's a lot of concepts held in that, and they're not all the same concept, but it kind of works for all of them.
Okay.
So
that's good because what I'm also taking from that is, again, it's like the build we were talking about before, but it's also like once I get my head around that stuff, I can use that understanding into, it's sort of like a foundation into more complex things.
Into other things, and you find these rules actually work. Whatever we're doing,
right.
Right,
I've quite seen that before.
Still doing those same things. Thank you for watching.